Hello and welcome to this project on plant disease detection. In this project, we will create a convolutional neural network that will be able to predict whether a plant is suffering from a disease or not. We will be using different layers and other hyperparameters for building, training, and testing this classification model. This model is mainly built using TensorFlow and Keras. Now let's see what are the steps we use to solve this problem or to make this project. So firstly, I will teach you how you can mount your Google Drive on Colab Notebook. It is useful because you only need to upload your data on your Google Drive and you can directly connect it to your Colab Notebook. Second, we will visualize how the images look that we are working on. The images that we have, the dataset that we have, we will visualize that. After that, we will find out the means of all the dimensions and resizing them according to the images. Next, we will convert the images into a NumPy array and we will normalize all the images. This is important. Next, we will check the class imbalance, if the data is divided equally in the classes or not. After that, we will split the data and perform one-hot encoding on the target feature, that is the number of classes. Next, we will create the model architecture and compile it, and then finally we will fit the model using the X-train data, Y-train data, and also use the validation data. After that, we'll plot the accuracy and the loss against each epoch to see how the model works, how the model is learning. Then we will move forward to pre-process the test data and use it to make predictions. In the end, we will visualize the original and the predicted labels for the test images. So what is the use of this project is that currently human society needs to increase the food production by an estimate of 70% by 2050. And it is predicted to be over 9 billion people. Currently, infectious disease reduce the potential yield by an average of 40%, which means that out of 100, we get only 60% of the crops that are yield every year due to infectious disease. And the widespread distribution of the smartphones among crop growers around the world, with an expected 5 billion smartphones by 2020, offers us the potential of turning the smartphone into a valuable tool for diverse communities. So what we can do is, this project can be converted into an app which can be used by different farmers to diagnose whether their plants are going through any diseases or not. So that is the main use of this project. This project will revolutionize the agricultural industry. So now let's move forward and see how we can make this project. For this project, we will be using Google Colab, as Google Colab provides high computational power and CNN requires that. So as we already discussed, in this project, we will be creating a CNN model, which in turn will be able to predict whether a plant is suffering from a disease or not. We will create this model using different layers and other hyperparameters. Then we will train and test this model. It is a classification model, and basically we have used TensorFlow and Keras for this project. So let's get started. So in order to get started, we will first connect our Google Drive to our Colab notebook so that we can directly take data from our drive. For this, we first need to upload the data on our drive and then mount the drive on Colab. This step here from google.colab import drive and drive.mount will help us mount our drive to Google Colab. You need to upload the data on the drive before doing this. I have already uploaded the data on my drive. So let's run this cell and mount my drive to Google Colab. So here, in order to mount the drive, we need to provide a authorization code which can be generated using this link. Let me go to this link. So this is the Pi Analytics account. I'll allow that. And this is the verification code. I need to copy this. You can paste this authorization code here and press the enter button. So here you can see that it has mounted our drive. So our first step is completed. Now let's move forward and see what are the contents in my drive. So for that we need to run this command ls and we need to set this path, my drive. Let's run this and see what are the datasets or what all data I have on my drive, so that I can exactly locate where is my data that I will be using for this project. So here you can see that on my drive I have Colab notebooks, plant images.py analytics. This is the images that we are going to use. So now let's move forward. So here comes an important step. Here I am importing all the required libraries. So as we are making a CNN model, we'll import all the required layers like activations, optimizers, and all other layers like conv2d, max pooling 2d, and all that. Also, we are importing some of the basic libraries such as NumPy for mathematical computation, Pandas for data frame operations, Matplotlib for visualization. We'll use CV2 that is OpenCV for image processing. Now let's move forward. So initially here, let's run the cell and import these libraries. Imported. So initially, let us observe what are all the images that we have in our dataset. This dataset contains 3 folders, that is 3 classes. So I am taking one of the classes and visualizing the images it contains. So here you can see that I have taken the potato early blight folder and I am visualizing the 12 images from this particular folder, from this particular plant disease. So here you will see that we are using the plt.imshow function, which is defined under Matplotlib, and it will help us to visualize. Here you can visualize the images, and you can see that all the images are in the size of 256 by 256. Now let's move forward and convert our images into array. So after visualizing, we will create these images into a NumPy array. It is required because we will need to normalize our dataset after this. So here I have defined a function which will convert my images into our images that we are using for this project into a NumPy array. Let's run this cell and create this function. So after creating the function, let us call this function and create all the images, convert all the images into a NumPy array. Here you can see that I have provided the path as plant images Pi Analytics, which contains 3 other folders, and the labels for these folders are corn common rust, potato early blight, and tomato bacterial spot. So we will be working on these 3 plant diseases. Let's run this cell and convert all the images into a NumPy array. It will take some time because we have around 900 images. So here you can see that this cell has run. So all our images have been converted into a NumPy array. So next step is we'll observe the number of images under different classes. This is important because we need to see if the data set is balanced or not. So let's run this cell and check this out. So here we can see that all the three classes have 300 images in it. So our data set is balanced. Now let us observe the shape of the image. Here I am using the image list 0, that is the first image, and the shape of the image is 256 by 256, as we have already visualized that in the above cells. Also it is of 3 channel, that is RGB, because it is a colored image. Next, let us check the total number of images, which is the length of all the labels list. So here we can see that it is 900. So we have a total of 900 images, which we can also see here. 3 classes with 300 images, which becomes a total of 900. So next step is to test, train, split the dataset. So we are using sklearn train test split to split the dataset into testing and training. Here you can see that I have taken the test size as 0.2. So my data will be divided into 80% training and 20% testing. Let's run this cell and divide the data. After this, we'll normalize the dataset of our images. For this, we are dividing it by 225 and we are also reshaping it. So now let's run this cell and perform this pre-processing of our images. It will take some time because it depends on the number of images. It's done. Next, what we'll do is we'll create that data, we'll convert the data into categorical, that is one-hot encoding. So one-hot encoding is necessary because if we don't do one-hot encoding for the target feature, the machine will try to prioritize it. So we'll perform this using two categorical function that is already defined under Keras. So let's run this and do one-hot encoding. It's done. After this is the main step. Here we will create the network architecture for the model. Here you can see that we have used different types of layer according to their features, namely conv2D, max pooling 2D. Max pooling is a downsampling techniques which is used to take out the maximum value over the window defined by the pool size. We have also used the flatten layer, which is required before the dense layer. So we have also used dense layer. In the final layer, you can see that I have used 3 neurons because we have 3 classes and the activation is softmax, which is the activation function for classification problems. It provides us with the probability of each class. So here we have created the model and we are also printing out the summary. Let's run this cell and find out the summary of our model. So this is the summary of our model. Model is of sequential type. It contains these layers as we have already defined. And the total number of params you can see here is 7244995 and all of them are trainable. So now let's move forward and we'll compile this model. So while compiling the model, we have set the type of loss to categorical cross entropy. We have used categorical cross entropy as we are working with categorical data and it has 3 classes. Similarly, we have used the optimizer as Adam and metrics as accuracy. Let's run this and compile our model. It's done. Next, we also have to split the data into training and validation dataset. So we are doing this using the train test split defined under sklearn. Let's do this and split the data. And one of the important steps is to fit the model. So we are fitting the model and finding out the accuracy on each epoch. Here I have used different epochs. Right now I am showing you with the 50 epochs. I have trained it on different epochs and find out the accuracy. You can also do that. You can change the number of epochs and fit it again and again using different number of epochs to test whether you are getting a good accuracy or not. So now let's run this and see how our model is getting trained. As I have used 50 epochs here, It will take some time. Let's see how much time it takes for the first epoch. So it took around 9 seconds for the first epoch. So it will complete in around 4 to 5 minutes, I think, or maybe even faster, as you can see here. Here you should observe that the accuracy, this is the accuracy here. You can see that it is 0.9686 in the fifth epoch, and the validation accuracy is around 1, which means that the model was overfitting at that point. But as we move forward, the training accuracy is becoming 1 and the testing accuracy is also becoming 1. So as you can see here, we have run this model for 50 epochs and both the accuracy is 1. Now we will save this model. While saving this model, I have used different techniques. First one is we'll saving the model using the H5 format using model.save command. Similarly, we can also save this model into a JSON file. This JSON file will be saved on our drive with the name of plantmodel.json. And we should also save the weights of the model if we are doing it in a JSON format. So we are also saving the weights using model.saveweights. Let's run this and save our model. So this will save our model directly into our drive. Next, we will plot the training history. This will show us the accuracy of the model throughout the training. Let's visualize this. Here you can see that after 20 epochs, it was same training and validation accuracy. Now let us evaluate this model to find the accuracy of the model. Here we are using model.evaluate function to evaluate this model and printing the test accuracy. So the test accuracy that we got is 99.44, which is a very good accuracy, and a loss of 0.0072, which is very low. So our model is doing good. Next we'll see how our model predicts. So we'll pass an xtest data into ypred and predict it using model.predict. Let's run this and save our predictions into ypred. We will also plot images to compare. So let us take any image. So I have taken the xtest 10th image. This is an image which we have taken. Now we'll print out the prediction for this, which means that we'll print out the original label for this image and also the predicted label for this image. So now let's run the cell and see how our model is performing. So as you can see here, the original label for this image was potato early blight and the predicted is also potato early blight, which means that our model is accurate. So with this, we came to an end of our project. We started with loading the dataset into Google Colab using the Google Drive, and we visualized the images. Next we did is normalize the images, which is important. Then we created a CNN model. You can also create a CNN model in this same order, or you can change the number of layers according to you. Not only number of layers, you can also change the kernel size, the pool size, and every other hyperparameter. This model is used for predicting the plant diseases using the images that is supplied to this model. This model is highly beneficial as it can be used by different agricultural firms and farmers to increase their yield and to stop the wastage of crops due to different diseases. Next, we will see how we can create a deep learning app of this using the Streamlit. So let's move forward. Now we will see how we can create an application of our plant disease classification model. So here, now we will see how we can create an application of our plant disease classification model. So here I will show you making an app using Streamlit. So Streamlit is an open source Python module, Python package, which can create standalone applications of machine learning and deep learning. So here you are seeing that I have created a .py file, that is a Python file. It is a Python script which will run our application. So let me take you through it and explain you how you can do it. So first you need to create a folder for this model. So here you can see that I have already stored the model here, which we have downloaded from the Google Colab here with the name plantdisease.h5, and this is the main app that I am creating. So let me show you how to create this app. Let me take you through this app. So first we need to import some required libraries. We are importing NumPy as NP. We are using Streamlit. We are using CV2, that is OpenCV, for image processing. And also, in order to load this model as we have stored here, we need to use the keras.models import load model. So in this, our first step should be loading the model. So in order to load the model, we need to provide the path for the model. So here you can see that I have provided the path for the model. After providing the path for the model, let us start with building the app. So firstly, let me create a list of all the names of the classes that we are working on. So we are working on corn common rust, potato early blight, and tomato bacterial spot. So I have created a class names list and passed all these classes here. The next step would be setting the title of the app. So as we are working on plant disease detection, so I have used st.title function and set the application title as plant disease detection. Similarly, I have taken st.markdown, which can be used as a subtitle, and I have set it as upload an image of the plant leaf. You can use certain different functions like st.heading, st.write. You can check those out also. So next, I will ask the user to upload an image and store it into a variable. So the plant image is a variable which will store the image uploaded by the user. We are uploading this file using a st.fileuploader. Also here you can see that I have specified the type of the image. So it should be a JPG. You can change it to PNG or any other image format. And I have created a button after this, which will store the prediction, which will store the user input into submit. So this button will be shown as predict, and as the user clicks on it, the click will be stored in submit. So if submit means if user clicks this, then it will check if the image is not none, and if the image is not none, then it will convert that image into an array. After converting that image into an array, we will convert that image into a OpenCV image because we need to perform some operations on it. So after converting that image into an OpenCV image, first we will display the image to the user. Also, we'll see the shape of the image that we have uploaded. After that, we will resize this image because our model takes an image of 256 by 256. So here you can see that I'm resizing the image. After that, we need to convert this image into a 4-dimensional image because our model takes a 4-dimensional image. So here you can see that I have used OpenCV image.shape function and converted into a 1 by 256 by 256 by 3 shape. After this, we just need to predict it. So for prediction, we have used model.predict and passed the image that we have taken from the user. And after this, we have stored into a variable name ypred. Here you can see that for the result, I have used class names as we have defined above. We are using 3 classes, so it will fetch me the correct class for this particular image. And after that, we will print that using st.title And here you can see that I have used the result and split it into this type of function. So it will show me that this is a, whichever class it is, leaf with particular disease. So this is the main application that I have created. So there are certain dependencies before running this application. And for those requirements, those dependencies, we need to create a requirements.txt file. So let me show you how you can create a requirements.txt file. So for creating that, let us move to the folder where we have let us move to the folder which names as plant disease and copy that location of the folder. After copying the location of this folder plant disease, we will open the Anaconda command prompt. So in Anaconda command prompt, we need to go to that folder where we have our project stored. So I have already copied the location of that folder. So now I'll use cd space location of that folder and go to that folder. So here we are going to create a requirements file. This requirement file will contain all the dependencies, which means all the libraries that are required to run this particular application. So for creating that, we need to run a command named pip reqs. And if you don't have pip reqs installed on your system, first we need to install that using pip install pip reqs. So what this will do is this will install pip reqs on your machine. So here you can see that on my system requirement is already satisfied because I have already installed that. You can install that in the same procedure as I have shown you. So next what we'll do is now we'll create the requirements.txt file. Why this is important? Because this will install all the libraries that are required to run this application on your system. So let's run the command pip reqs. It will run through all the Python files that I have stored in this particular folder, and it will return me all the required dependencies with their versions that I have used in my Python code and create a file name requirements.txt. So here you can see that it has created a requirements.txt file. So now let us install these requirements. So for installing these requirements, we will use pip install -r requirements.txt. So what this will do is this will install all the requirements that are listed in this requirements.txt file. So I have already installed all these. So this is showing me requirement already satisfied, but you can do it in the same way. So next I will show you how to run this app. As we have installed all the dependencies and we have created our main app. So let me show you how you can run this on your local machine. So for that, we need to run this command streamlit run and the name of the file. So my name is main_app.py. My project is with this name. So I'll run this and it will launch my app into a local browser with this particular URL, as you can see here. So let's go to the browser and check out our app. How is it looking? So here you can see that this is the main homepage of our app. Other than the titles and the functions that we have created, you can also see that there is a menu on the right hand side. As you click that, it will show you different options of Streamlit. You can rerun this, you can clear the cache, you can deploy this app directly using this. This is a pretty good feature as you can use it to deploy these apps online without any hassle. You just need to upload it to your GitHub account and use this. Other than that, you can record this whole screen. it contains all the documentation. You can ask a question to the community. You can report a bug if you have any, if you see any bug in Streamlit, and all the functions. So let's come back to our app and see how it works. So let me click on browse files and select a plant image, and then we will predict it. So here you can see that I have uploaded a file here. Now let us predict it and find out which image it is. So which plant disease it is. So here you can see that the size of the image is 256 by 256 by 3, and this is a tomato leaf with bacterial spot. So by this we came to an end of this project. You can try different Streamlit functions like title, sidebars, and all that to make it more interactive, to make it more interesting. Thank you.